attention all flight crew members. This is the final go-no. We have liftoff.
Imagine a silent night sky. Now picture that silence shattered, not by alien broadcasts, but by the satellites we built to connect the world. Starlink is leaking mysterious cosmic static, and what we're losing might just be the secrets of the universe. Today we're peeling back the velvet curtain of the cosmos and finding something unexpected. Starlink satellites are leaking signals, not the internet beams we aimed for, but mysterious radio noise from the electronics themselves. And this accidental interference, it's drowning out whispers from the farthest reaches of time. Curious yet? Let's go. So what's happening? Let's break it down. Astronomers at Curtin University, using a prototype station of the SKA Low Radio Telescope, sifted through a mind-boggling 76 million full-sky images over nearly a month. Their findings: 112,534 instances of radio interference traced to 1,806 unique Starlink satellites. In some datasets, nearly 30% of images showed interference from these satellites. This isn't a one-off glitch, it's systemic. Why it matters: these satellites are flooding the skies with unplanned signals, even in frequency bands strictly reserved for astronomy, like 150 MHz, where 703 satellites were detected flickering in that protected range. This interference comes not from their intended transmissions, but from unintended electromagnetic radiation, UEMR, likely leaking from onboard electronics. Because it's unplanned, astronomers can't easily filter it out. The stakes: why it's not just a bump in the data. This isn't just a tech glitch, it's jeopardizing our window into cosmic history. Radio telescopes are astronomers' time machines, tuning into the faint glow of neutral hydrogen from the early universe, tracing back to the epoch of Ryanization, the cosmic dawn when the first stars ignited. These signals are thousands of times weaker than the hum of modern electronics. But now, the leaked radio noise from Starlink acts like a bullhorn drowning out a whisper. 7 million Janskys at the dish in some cases, so loud it outshines the Milky Way. Just imagine the magnitude: artificial noise overpowering the cosmos itself. The worst case scenario: experts warn of an inflection point. If satellite mega-constellations keep growing unchecked, ground-based radio astronomy could become impossible within decades. What models are the culprits? Not all Starlink satellites are equally noisy. The V2-Mini-Q and V2-Mini direct-to-cell models are heavily implicated, about 76% and 71% respectively. These newer generations are bleeding more noise than earlier iterations. One study even found second-gen models emitting up to 32 times stronger UEMR than first-gen versions. Echoes of FM radio, around 99.7 MHz, bouncing off satellites were also detected, like cosmic karaoke. Why this leak happens and why it's so sneaky: regulations focus on intentional transmissions, not accidental ones. That means SpaceX isn't technically breaking any rules, even when those leaks land in radio-protected bands. It's like there's a legal loophole for unintended transmissions. Astronomers are hunting for changes at the ITU, International Telecommunication Union. They want new rules that protect against UEMR leaking from orbit, much like EMI standards for electronics on Earth. But policy shifts take time. Can SpaceX fix it? There's hope. Visible light pollution from Starlink has already dropped thanks to satellite orientation and dark coatings. A similar approach, shielding electronics or deactivating components when flying over radio telescopes, could reduce radio leakage. SpaceX already blanks its internet beams above observatories. Extending the same to background electronics could help. But once satellites are launched, leaks are hard to fix. Astronomers insist testing for UEMR pre-launch must become standard. The triple threat, multi-constellation future. Starlink is just the beginning. Soon, we'll see Amazon's Kuiper, OneWeb Eutelsat, China's G60 and more, each with thousands of satellites. Combined leakage could turn the sky into radio static. If we don't act, regulate, enforce, design better, we may permanently close the cosmic window we've only just begun to open. Fueling inspiration. Why this matters. So why should you care? Because these signals aren't just noise, they obscure cosmic history. The first stars, the structure of the early universe, how galaxies formed, These discoveries depend on keeping space radio quiet. This challenge highlights the ongoing tension between tech progress, global connectivity, and scientific heritage, unlocking our cosmic past. The solution lies in smart collaboration, forward-thinking design, and shared respect for the skies. Ultimately, it's a powerful reminder, even our greatest creations, satellites beaming internet, can cast unintended shadows across the stars. The human side of the story. What's at stake for us? Let's pause for a moment and bring this back to us, because it's easy to hear radio astronomy and think it's some distant niche science with no real impact on our daily lives. But here's the thing, every big leap in human knowledge started with people asking questions about the universe. The discovery of cosmic microwave background radiation, that's how we confirmed the Big Bang. Mapping radio signals from pulsars, that helped lead to GPS technology, the same thing guiding your phone right now. Observing faint signals from deep space, that has improved climate science, communications, even disaster prediction here on Earth. So when Starlink's mysterious leaks threaten these signals, we're not just losing stargazing opportunities, we're risking future discoveries that could change human life. And here's the part that should give you goosebumps. The signals we're missing now could include evidence of planets like ours, or even hints of extraterrestrial life. If the early whispers from the cosmos get drowned out by static, we may never even know what we lost. The bigger picture, satellites, mega constellations, and the space traffic jam. Now let's zoom out. Right now, there are over 6,000 Starlink satellites in orbit. Plans call for tens of thousands more. Add Amazon's Kuiper project, OneWeb, China's proposed constellations. Suddenly, low Earth orbit is starting to look like a cosmic highway during rush hour. More satellites equals more signals. More signals equals more interference. More interference equals less cosmic silence. And guess what? Radio telescopes don't just need silence for fun. They're listening for the faintest traces of hydrogen from 13 billion years ago. That's like trying to hear a single drop of water falling in the middle of a roaring stadium. Now imagine if the stadium suddenly got 10 times louder. That's what astronomers are dealing with. The mystery factor. Could these signals teach us something new? Here's a wild thought. While scientists see these signals as unwanted noise, what if there's a chance to learn something from them? These accidental leaks reveal a lot about the electronics, energy patterns, and shielding quality of satellites. Engineers could use this data to design quieter, more efficient spacecraft in the future. And here's the fun part. Some researchers are even speculating whether these accidental signals could be used as a kind of cosmic radar, bouncing off objects in space we can't normally see. It's a long shot, sure, but history is full of accidental discoveries. Penicillin, microwaves, X-rays, all came from scientists noticing something unexpected and asking, wait, what's this? Could Starlink's mysterious signals end up revealing something unexpected about space itself? Maybe. The race against time. Why action can't wait? But here's the problem. By the time policies catch up, tens of thousands more satellites could be up there. Astronomers warn of a now or never moment. If nothing changes, ground-based radio astronomy may be permanently crippled in just a couple of decades. The Square Kilometre Array, the world's most powerful radio telescope under construction, will be ready soon. It's designed to peer deeper into cosmic history than ever before. But without stricter noise regulations, its detectors could be picking up internet static instead of signals from the dawn of time. That's like building the Hubble Space Telescope, only to hang Christmas lights in front of its lens. So here's what you need to remember. The space between us and the stars is fragile, and our climbing satellite mega constellations are threatening to clutter it with noise. If we don't act, clean up the leaks, demand better design, we risk losing the echo of the universe's birth. Let's stand for science, demand clearer regulations, and protect our cosmic heritage. If this made you wonder, if you feel that spark to know more, subscribe, share, and keep looking up. Because the answers to life's biggest questions are still out there, waiting in the quiet. Let's not let it be silenced.